Okay, so here we are going to discuss the different techniques, that is, this is about the interpret design. Okay, we are designing this interpret driven IO. What happened is that there is two problem in interpret IO. Which device interpreted and which interpret you have to handle first. Okay, so the two problems which is happening here is that first we have to find which device has been interpreted. If there are two or more devices, we have to make it has to be decide which interpret we have to handle first. So you have different type of techniques, that is multiple interpret lines, software pool, daisy chain, bus architecture, bus arbitration. Okay, so here the first technique is a multiple interpret line. In multiple interpret line, each device would get, that is each of this device, if you see, it will get its own CPU. It is like each of this device is connected to a CPU. And in software pool, what happened is that CPU detects the interpret, asks each device positive, it's slow, checks one of the device at a time. So ask each of them, CPU would ask each of this device whether it was by whom. If device 1 gives the interpret or device 2 is give the interpret, if the CPU in interpret service routine time, if it detect a interpret, it will ask each of the device, which is actually a very slow process, which device has given the interpret, it will ask in each of this device. Now in technique 3, this is daisy chain, which is like here software pool, this is hardware pool. Here what happened is that the acknowledge signal travel device to device. The requesting one grabs it and sends back a vector. So that means here what happened is that the acknowledge signal, like if D2 is giving the interpret, then acknowledge signal would go from the CPU to this, like each of the device, from then only it will reach the D2. It's like a chain. And D2 would send back, like if it has to, the device ID, it has to reach the CPU, then it will send back to CPU like this. Bus architecture means devices device compete to control the bus first. That means only one can raise interpret at a time. So that means at the bus, each device would compete to get the bus. Only one device would able to send the interpret at a time. So the winner can send the vector and CPU can handle. Vector means winner can raises interpret, and like if it raises an interpret, that is what it means. Okay, then it can give it to the CPU. We can understand each of them in detail. So let's see what are the two design problems. The two design problems is when multiple devices exist, how can the CPU know which one caused the device? That is a one problem. And the second, if the several interpret happen at once, which one get to handle first? So first, for the CPU, the first problem is that CPU has to find which device has caused the interpret. And also the first thing is that when multiple devices is connected, when multiple devices is existing, how does the CPU know which one caused the interpret? If there is multiple devices which is connected, how could CPU know? How do CPU know whether which device caused the interpret? And if also these devices is taking like more, let's say 3 devices give the interpret at the same time to the CPU. So how do CPU choose which device interpret it has to choose? These are the problem. The first problem is when multiple devices is there, how does the CPU know which has caused the interpret? If several interpret is happening at the same time, how do CPU decide which to handle first? These are the problems, two design problems which is there. So 4 solution exist. Here is the multiple interpret line, software pool, daisy chain and bus arbitration are the 4 solution to this. Okay, multiple interpret line means it gives every device its own dedicated wire to the CPU. So it is easy to understand but totally impractical. As you scale up, you need 100 of wires. So that means the first thing is that each of the device would get its own CPU. Each of this device is attached to the CPU by a wire, but it's actually impractical. Impractical means impractical. Why we have lot of devices, lot of external devices, so you may have a lot of wires would be required. So this is considered to be impractical. This is called as multiple interpret line. Now in software port, one shared interpret wire, that is one interpret wire would be there. When the CPU detects an interpret, it runs a routine that goes around asking each device, was it you, one by one. Works but wastes time. Imagine checking every door in the building to find who knocked, right? That means in software port there would be one shared interpret line, interpret wire. One interpret wire is only there, and what happened is that when the CPU would ask each the devices whether you have given the interpret, whether you have given the interpret, it will go and ask the each device. So each device it will ask, the CPU would ask whether this device give the interpret or whether this give the interpret. So there is a one interpret wire, only one shared interpret wire is there, and CPU detects, when CPU detects an interpret, it would run a routine by asking each device whether that device give the interpret, whether you give the interpret, like that. But it is wasting a lot of time. This is called a software poll. Now next is daisy chain, which is known as hardware poll. It is a smarter version where all devices share one interpret request line. So there's a this is like considered to be much more smarter. Here what happened, the CPU sends acknowledge signal that passes through each device in the sequence. The guilty device grabs the signal and sends back a vector, that means which is given the interpret, that would grab the signal and send back a vector, means its unique ID or address. The CPU uses that vector to jump straight to the right handler, no guessing needed. This is called as vectored interpret. So here what happened is that in daisy chain, what happened is that there is only one interpret request line only. All these devices are connected like this, D1, D2, like that. So acknowledge, when in CPU receives an interpret, what happened is that this is all a shared request line, interpret request line. The acknowledge signal will go to each of the device, which caused the problem, which caused the interpret, that will send the vector back to CPU. Vector means it's vector, it's the device has a unique ID or address, right? That it will send to the CPU, and then using this vector only the CPU can jump straight to the handler, that is, so using this vector CPU jumps straight to the right handler. This is also called as vector interpret, right? Because this, only by knowing the address of the device only we can do the next interpret handling code and all, right? Then only we can interpret service routing code and all. So in order to do that we need to know the address. So what happened in the daisy chain, it is only a single interpret request line is there, and the CPU would send acknowledge signal to each of them, like this. CPU would send acknowledge signal, and which caused the problem, that device would, the guilty device which caused the interpret, that would send back the vector signal. So vector signal, when it reaches the CPU, it can do whatever it is needed, right? So here this is also called as vector interpreted. Now in bus arbitration, another vector approach is the bus arbitration. Here what happens, if you see, device must first win control over the device must win the control over this shared bus, and that winner shared bus before they can even raise an interpret. So only one device can shout at a time. Once it wins, it sends its vector and the CPU would handle it. This solves both problems, no conflict, and the CPU knows who to talk exactly. When there's a shared bus which is shared between lot of devices, the winner would get this shared bus. So the device must win the control over the shared bus before raising the interpret. Then the winner can raise the interpret and can send vector to the CPU. So device compete to control the bus first. Only one can raise interpret at a time. So only one would, so because of this, before getting interpret itself, it is getting the control of the shared bus. So at a time only one can raise the interpret. So winner sends the vector and CPU can handle it. The priority problem, which interpret to handle first, is typically solved by assigning priority level to the device. Now when lot of devices are sending the interpret at once, we have to decide which device you have to handle first. So there is each of these devices giving some priority levels, okay, priority levels would be given either through the daisy chain order. That is, the daisy chain order would be in the priority. The first device would be high priority, like that. So devices earlier in the chain win, like that. Or through a dedicated interpret controller chip like Intel 88659A, which manages up to 8 interpret level and can be cascaded to handle 64. That means this chip is an interpret controller chip. Through this interpret controller chip also this priority problem can be handled. It can manage up to 8, that is Intel 82C, right, Intel 82C 59A. So this chip can basically control the interpret. It can manage up to 8 interpret level, or when it is cascaded it can manage up to 64. This is how the priority problem is solved. Okay, so only here, only at a time only one can send the interpret, because before sending the interpret itself it has to compete to control the bus first. Then after that only one device would raise the interpret, and it will send its vector to the CPU, so the CPU can handle it. Okay, the priority is like each of the device has a priority, like how you arrange it in a daisy chain, or through an interpret controller chip like Intel 82C59A, like that. So this is how the problems are basically solved. Thank you.